Now we are going to discuss about the performance of reciprocating pump test rig. So we know that one, what is meant by the pump? The pump is what? Converting mechanical energy into the hydraulic energy, means pumping the water from lower head level to the higher head level, means from the sump to the delivery tank, overhead tank. Now I am going to explain the parts of this pump. Here we can see that here is the measuring tank, the scale is there. With the help of this scale and with the help of the stopwatch, we are going to measure how much of the water is collected for a 10 centimeter height or a known height in the measuring tank. Next, this is the energy meter disc. From here what we are going to find out how much of the energy is consumed. Here is the disc is there. For a 5 rotation of this disc, how much of the time is consumed. Based on that one, you are going to calculate the energy consumed by the pump. Here once again what energy meter constant is there, 1500 revolution per kilowatt hour is there, that is used for the calculation purpose. And this is the gauge that measures the delivery pipe, and this is the pressure gauge, measures the suction pipe. For the calculation purpose, we required energy meter reading and the speed. For the calculation, we won't use the speed. Later, this pressure is required, delivery pressure is required, vacuum pressure is required, and later this how much of the water is collected for a 10 centimeter height, how much of the time is taken to collect 10 centimeter of water, that should be noted down using the stopwatch. These are the things is required for the calculation purpose. Here we can see that, so this is the reciprocating pump, this is the double acting pump, double sided pump, this is one, and this is the motor. From the motor we are transmitting the energy to the reciprocating pump. See, here you can see this is the suction pipe. The pipe is connected to the sump, and also this pipe is what below the reciprocating pump. Here is also valve is there. By operating this valve also we can conduct the experiment. And this is the delivery pipe. Here you can see that this tappings, this wire, this tube is connected to the delivery pressure gauge, and this pressure tappings is connected to the suction pressure gauge. And this is the delivery pipe. This is the valve control for the delivery pipe. We will conduct the experiment by controlling this valve. For different readings, just operate the valves for the different flow rate, conduct the experiment. Now I am going to show how to conduct the experiment. Now I am going to on the pump. While onning the pump, already I set the delivery pipe valve. I will conduct the experiment. I will start the experiment. From that one, what I should note down the vacuum pressure or suction pressure, both are the same thing. And this is the delivery pressure. Once again, the delivery pressure in what, in kg per centimeter square is there, the unit, and the suction pressure, the unit is in millimeter of mercury. Later I have to convert into the kg per centimeter square. Those things I am going to explain in the calculation part. And the speed should be taken. At the same time, how much of the energy meter disc is rotated for a 5 rotation, how much of the time is taken, that is also to be noted down. Now I am going to on the experiment. So this is the switch. Now I already on the pump. Here you can see that there is a change in the vacuum pressure. This should be noted down. At the same time, this is the delivery head, the pressure, that is also should be noted down. And here from the energy meter disk, for a 5 rotation of the disk, how much of the time is taken, that should be noted down from stopwatch. Later, how much of the water is collected for a 10 centimeter height. Note down the time taken to collect 10 centimeter of water. The experiment is repeated for the different flow rate by operating this valve. Okay, just now we completed the experimental part of the reciprocating pump. Now I'm going to explain how to do the calculation of the in the reciprocating pump experiment calculation part. So in our lab, the experiment is double acting reciprocating pump. This is a sketch. Now come to the observation. The following observation are noted down. The first is what? Area of the collecting tank, energy meter constant is taken from the energy meter, efficiency of the motor is taken as 75%, diameter of the piston in the reciprocating pump, or the diameter of the piston, that should be noted down, a meter, and the stroke length, what is the stroke length, and that is also noted down from the experimenter. And using diameter, calculate the area of the piston. Here you can see that one. Here, stroke length as well as the diameter of the piston is given in the experiment itself, and the area of the collecting tank is also given in the experimental setup. So those values should be noted down for the further calculation. Once the observation is over, the next is the tableau column. Here, the the calculation part is almost similar to the centrifugal pump. Here we were going to take the following readings. We will take the pressure from the suction head and from the delivery head. Then time taken for H is equals to 10 centimeter height. How much of the time taken is time taken to collect the water? That is the time taken is not on here. Based on that, we're going to calculate the Q actual. Next is the output power. Once output is over, next is the number of revolutions of energy meter disk, time taken for that revolution. Suppose k is equals to 5. How much of the time is taken to rotate 5 rotations? Those time taken is not down here. Then next the input power, then output power, means efficiency, output power by input power, theoretical discharge, and percentage of slip is calculated. Now we'll go one by one. First is what? Suction head and delivery head, total head. This is suction head and delivery head is taken from here. Delivery head is taken from here. Suction head is taken from here, from the suction, from the pressure gauge. Here, here, this suction head in terms of millimeter of mercury, that should be converted to the kg per centimeter square, because delivery head is also in kg per centimeter square. To convert millimeter of mercury to kg per centimeter square, the following calculation has to be done, means just divided by 760. Here in mm of mercury is there, that should be converted into kg per second square. That is done by what is the value obtained divided by 760. That will be converted to the millimeter of mercury to the kg per centimeter square. After this, HS as well as HB is going to convert it into the meter of water. Just multiply by the 10. HS plus HD whole multiplied by the 10, that will be obtained as the what in terms of meter of water. This is the total head. Next is total time taken. Total time taken for H is equals to 10 centimeter height. What is the time taken? That is noted down from the with the help of the stopwatch. Then we have to calculate the Q actual.
Q actual is calculated by this equation, area into, this is what, A means area of the collecting tank, H is the height of water we have decided to consider, and T is the time taken to collect that known amount of height. From this one, what you can find out the actual discharge. Once the actual discharge is over, next you have to find out the output power. Output power can be found out by using this equation. Here, rho is the density of the water. G is the acceleration due to gravity, 9.81. Q is the discharge. That is what that is calculated from this equation. This is calculated from this equation. And H is the total height. This is the H total height calculated from this one. HS plus HD into whole multiplied by 10 is the total height divided by 1000. That will what output power will be used. After output power, next we have to calculate the input power. Here we are going to assume K is equals to 5 rotations or 5 revolutions. For 5 revolutions, how much of the time will be taken? That should be noted down here. Note down here. That should be used for the input power, calculation for the input power. Input power, the equation is what? K into 3600 divided by EMC into T. K is the 5 revolution, T is the time taken for complete the 5 rotation. EMC means energy meter constant, that is available in the experimental setup itself. In this energy meter, what here energy meter constant is kept or written here, that should be noted for the calculation purpose. That is the EMC taken here. So calculate the input power. Once input power is over, next is the efficiency of the compressor, output power divided by input power into 100. Then this theoretical discharge can be calculated by using this equation, 2 into A into L into N. This A means area of the piston, L is the stroke of the piston, and N is the speed of the pump. 2 because 2 already mentioned in our case, our reciprocating pump is what? Double acting pump. So that's why here we have to multiply by the 2. Then percentage of slip is Q theoretical minus Q actual divided by Q theoretical into 100. This gives the percentage of slip. So this is the what calculation part of the reciprocating pump. Thank you.